Components of a knitting machine. How are knits formed? While there are a variety of types of weft knitting machines on the market, they generally share similar configurations and parts. Yarn for knitting is positioned on creels or yarn holders, often above or next to the machine. Creels located on the side of the machine have an advantage because they're easier for technicians to access, allow more room for larger yarn packages, and prevent lint from yarn from falling into knitting elements. Yarn moves from this supply through various guides and stop-motion controls, as well as tensioning controls, before being directed to the yarn feeder. Proper tension is required for the production of quality products, and the tension may vary for different yarn types. Specialty tension controls exist for yarns containing elastic fibers, which are popular in knitted goods. On circular machines, the yarn feeders are fixed and evenly spaced around the knitting cylinder, and on flat machines, these feeders are stored at the side of the knitting beds and are brought to the active needles as needed. A specialty type of feeder that exists for circular machines is called a multi-feeder or auto-striper, which allows for more variety in yarn selection and for the creation of engineered stripe patterns. Certain flatbed machines also require specialized feeders for different effects, such as plating and inlay. The yarn feeders deliver the yarn to the needles where the knitting action occurs. There are three types of needles: spring beard, latch, and compound, but the latch needle is by far the most common type in weft knitting. At the top of each latch needle is a hook, and below this is a swinging latch attached with a rivet. Notice that the bottom of the edge or cup of the latch is curved to fit over and completely close the hook. At the bottom of the needle is a butt, which plays a part in controlling how needles activate, up or down. Usually, a machine will have needles with high butts and low butts, arranged in a way that allows for more complicated patterning. The needles sit in grooves called slots or tricks, which are evenly spaced along the needle bed for flat machines or around the cylinder for circular machines. The number of slots in 1 linear inch determines the gauge of the machine. Smaller needles are used on finer gauge machines, and larger needles are used on coarser gauge machines. On single knit machines, sinkers located between needles help control the fabric as it is being knit. A sinker is a thin steel element with a distinctive shape. This illustration highlights the parts. A sinker has a butt, a hold, a throat, and a nose. As the needle goes up to catch new yarn, the sinker moves in to hold the old loop. As the needle moves back down to form the stitch, it moves back out of the way and the fabric rests on top of the nose. Special sinkers with extra high throats can also be used to form terry loops. These extra high throats hold a long loop of yarn as it goes through the knitting cycle, forming the loops that are signature to a terry structure. The yarn is grounded with a second yarn that does not interact with the terry sinker, and the two yarns are plaited together. These sinkers can be activated to form patterns for function or design. The butt of the needles comes into contact with the cams, which control needle movement. The cams can be adjusted to control for stitch length and type, and there can be multiple sets of cams to control high and low butt needles separately. Sinkers also have their own cam track. On a circular machine, the cams are fixed in place, and the needles, held in place by the slots, move through the cams as the cylinder rotates. There is one set of cams for every feeder position on a machine, meaning one course of knitting is completed per feeder for every rotation of the machine. On a flat machine, one or more sets of cams are housed in a carriage which moves across the needle beds, which are fixed in place. The carriage will also select and move the yarn feeder as it travels across the bed. Electronically controlled knitting machines have the greatest ability to manipulate knitting needles. The needles still travel through stationary cams to control their movement around the circumference of the machine. However, electronic pulses act as magnets to engage or disengage each needle to either knit, tuck, or miss as it passes by each feeder. Full mechanical patterning machines may have cams controlled by pin drums, pattern wheels, or step jacks. In these cases, each set of cams must be manually set following the instructions of the design before knitting can take place. These machines are still widely used in the industry and so can contribute to higher run requirements or longer changeover times between styles. On double knit circular machines, a second set of needles is located perpendicular to the cylinder housed on a dial. This dial sits on top of the cylinder and houses needles in slots spaced at the same gauge as the cylinder. This second set of needles allows for the knitting of double knit fabrics and helps hold the fabric in place so sinkers are not needed. Most flatbed machines have two sets of beds, arranged in an upside-down V shape, which is why they are often called V-bed machines. More complex machines contain 4 beds to allow for advanced patterning and shaping of whole garments. Because double knitting and V-bed machines have 2 sets of needles operating simultaneously and could be directly opposite each other, special attention must be paid to ensure the needle positioning is correct for the type of knit construction being set up. The positional relation of the 2 sets of needles is called gating, and the 2 types are rib gating and interlock gating. When the needles are rib gated, they are arranged so that the needles from opposing sides fall between one another and all needles can activate without hitting each other. This is required for rib structures as well as other types of patterns. When needles are spaced directly opposite each other, it's called interlock gating. In this case, only 1/2 of the needles from each side can be activated at a time. This is used to create interlock fabric, as well as other styles such as ponte de Roma. After fabric is formed, it must be collected somehow. On circular machines, the fabric passes over a spreader bar before being taken up and rolled into a tube. On flat machines, the fabric passes between takedown rollers before being collected below the machine. In both cases, downward tension on the fabric is important for fabric formation. The downward tension can be altered within the knit program or manually on the machine.